These next two panels are really exciting because they're both the wow factor, the stuff we're all working on, the stuff that if we can make it work like we'd like to would be so impactful and so incredible. And we've got an awesome panel in both cases because we're going to do energy storage and then we're going to do AI. We'll probably start the AI panel with, can you help us figure out energy storage? But we got a great group. We've got Mateo Jaramillo. He's the CEO of Form Energy. And what you'll hear is they're a battery manufacturer. They have a very interesting battery technology. They're really aiming at creating the batteries we need to store electrons. And so his background is he was running Tesla's energy storage business. So he has seen a thing or two when it comes to batteries and electricity storage. Coming down the line, our friend Pat Wood. Pat, if you are a Texas energy or power person, you certainly know Pat. He was on the PUC here in Texas, was chair of it for George Bush W. And then he went to Washington, D.C. and did the same thing for the FERC. Now he's the CEO of the Hunt Energy Network. They're a consumer of batteries because basically what Pat is doing is patching the energy system anytime there is a lot of need or a reliability problem or something in the system that's not working. Pat and his team show up and put in a power system that makes it all work. But he's also a super optimistic guy. One time I called Pat and I said, if I have one more negative power conversation, I'm gonna, I need you. And so he will provide some sunshine. And then we've got Ashley Zumwalt-Forbes. As you can see, she's the Deputy Director of Batteries and Critical Materials, U.S. Department of Energy. All of this comes with a big discussion around how are we going to do it? How is the United States going to do it? There's a lot in this supply chain that as Mateo figures it out and Pat buys it, Ashley's got to make sure that we're getting it from the right people and doing it in the right way. So we got a supply chain right here. So welcome. Can I get a round of applause for these three? So Mateo, maybe I could start with you. You've got a great story. People should look at the Form Energy webpage and just read up on it. But it's a really neat story because not only is it technology and revolutionary and exciting, but it's happening in West Virginia. And the state has leaned in to be your partner, and you got a factory, and it's, this is happening, and it's a revitalization story as much as it is a technology story. But could you tell us a little bit about Form? And I know just last night you said you were on the factory floor, so you got here this morning, so we really appreciate you coming.
Yeah, thanks, Maynard, and thanks to everybody for being here today. Indeed, I was at the factory yesterday for what we call just a celebration of West Virginia. So we really were saying thank you to our employees, to the state of West Virginia. The governor was there, and the governor of West Virginia is a large man, and he has a large dog who made an appearance at the Republican National Convention, if you happen to see that. That dog is called Baby Dog, and Baby Dog goes everywhere the governor does, and it is perhaps the most quintessential case of dog looking like owner that has ever existed in that category. And so we made sure the Baby Dog got a dog like bandana that says Form Factory 1 on it, and he couldn't have been more pleased. So we were real happy to do that and really show what's happening at the factory. We have built that factory on an old steel mill location. So this is in Weirton, West Virginia, which is in the northern Panhandle. It's about 30 miles from Pittsburgh, Pennsylvania, and at a site that lost about 12,000 jobs about 20 years ago, or over 20 years, finished about 20 years ago. And so we got significant support from the state of West Virginia. They passed a piece of legislation to fund that project. And so we were delivering on that commitment. I gave the governor our first rent check there, which felt really good as well. And so we are commercializing iron air as a chemistry. So that means we're reversibly rusting iron in a battery. That's the reaction. This is a technology that was first studied in some detail in the 1970s, actually by Westinghouse under a grant that was provided by the U.S. Department of Energy. And so the lineage goes back some ways and back to the national labs discussion. That it's an example where investing in sort of core science has a return maybe decades literally later. But we picked up that technology because it's fit for the moment. And that moment is, of course, a grid which is increasingly driven by weather. Weather which is bad, weather which is good, but weather driven no matter what. And this type of technology, iron air, is very low cost and therefore can be made to be very long duration. So cost and duration go hand in hand inversely for batteries. And so our batteries are rated at 100 hours duration. You can, at the nameplate rating power, you can get 4 full days of discharge. And obviously that helps mitigate some of these weather intermittency challenges. You know, we have the daily intermittency challenge, sun going down every night and coming back every morning, but we then also have obviously longer dated intermittent challenges as well. Polar vortices or heat domes or you name it. And so that's exactly where our battery comes in. You know, the last speaker mentioned that we have about 3 minutes of combined energy storage for the electric system today, and our goal is to bump that up to maybe 3 hours, because that would really get the job done. And we have a 100-hour battery. The figures are going to be all mixed here, but you don't need a month of energy storage to solve the intermittency challenge on the grid, is my point. And we can get there with hundreds of hours duration and a good mix of asset resources that deliver the portfolio of the system. So that's what we're doing. Our first customer deliveries start at the end of this year. It's been 7 years of a wind-up. We're a venture-backed company. Some of our investors are here in the room today. Thank you to wherever they are. Thank you very much. And so we're just really excited to finally be at this stage and hopefully just about to really have a big impact on the electric system.
So, Mateo, just so we have a sense of it, if one of your batteries was in this room, how big is it? How heavy is it? Tell us just physically what one of these batteries looks like.
Yeah, and I should say NGP was the investor, not because we love them. So our batteries are meter scale devices. This is not a battery cell you can hold in your hand. These are a meter tall and 2/3 of a meter wide and weigh about 100 kilograms. That's our repeat unit. So in our factory, we're making the electrodes from raw materials. We're assembling those cells from components. We're turning those into complete modules and systems. And then the finished product looks like a shipping container. So, batteries operating should be as boring as possible. That's our goal. And that's what we're doing right now.
And I know it's probably going to change through time, but you can imagine in West Virginia, we're going to put that made in USA on the side. Like what the components now versus, looking into the future, like how much of all of that will come from the US?
Yeah, 100% is the short version of it. Right now, so we have a bill of materials that's about 800 items long. 4 of those don't come from the US right now. And we're in process of onshoring those last remaining 4 items. So imminently 100% domestically made and sourced product.
And of all those things, is there, because we always hear about the supply chain and that's what Ashley is aimed at, but is there a particular component which was the most difficult to get it done in the US?
Well, the most stubborn one in the end will be the chips that we use, the control boards that we use, because that's a condition that everybody has to deal with. But it wasn't particularly challenging. And frankly, that was one of the selection criteria that we had at the beginning of the company, was what kinds of materials are available, fundamentally cheap and abundant and safe. And as it happens, when you run that screen, you end up with materials that are also available already in the United States. So that was a happy overlap in the way that we went about picking the right technology to pursue in the first place.
All right, Ashley, I'm going to jump to you. I've got Pat Wood on deck, but you're in the Department of Energy, the DOE, you're looking at so many things. There's a lot of funding available. There's different things on the menu. People are coming to you guys for different things. How did you wind up in this particular vertical? What excites you about it? And maybe just tell us, I think we all know it's really hard to mine in the United States, but get us past that, because that's a very basic understanding of this part of the supply chain.
Yes. Okay. All right. So great suite of questions. You're exactly right. The challenges in front of us are extremely significant. Really excited about Forum's story, so thank you for going through that. My background's actually petroleum engineering. I took a little bit of a right-hand turn into the mining business, nickel and then copper, and then in January took on this role specifically to deploy bipartisan infrastructure law and Inflation Reduction Act capital into the battery supply chain. Very much an all of the above person, but also know firmly that we need more batteries across the board in this country. And particularly when you're looking at the supply chain, all the way back to mining, but not mining in a vacuum. It's really at every juncture of the battery supply chain. We need to bring that back to the U.S. If you're looking across the board, from mining into processing, into some of these more bespoke chemical manufacturing pieces, all the way through cell to pack manufacturing, the PRC far and away dominates. If you're looking at instances of cobalt, for example, which I know many of you will have emotional reactions to, graphite being another one, which is a little bit less prevalent in the news, but every bit as much challenged from a PRC domination standpoint. For those two areas, the PRC controls upwards of 95% of refined material, particularly when you're looking at the backdrop of export controls, which China continues to roll out, most recently putting in place an export control on antimony. We would be putting ourselves at a significant danger from a national and economic security standpoint to not develop those competencies in the U.S. And so my mandate specifically, my office oversees $20 billion in funding. This is some non-dilutive equity, so grants, for lack of a better term, but it's $6 billion. So 6 of the 20 billion is grants. The rest is tax credits. These tax credits are 48C and then 30D, for those of you who are familiar with the language of the bills.
I saw some people writing that down.
Oh, okay, so writing it down. I know. I start to get very popular when I talk about the numbers, but those are really across the board to bring projects to the U.S. and ensure that we're not just building factories to close on day 2 because unit economics are negative. That is what keeps me up at night. So as we are making evaluations and making investments across the supply chain, I need to ensure that these projects, once they're built, they're able to stay in operation long term, that they're able to compete on a head-to-head basis with China. Sorry, I really get on a roll.
Fantastic. Well, I just had one question. Yeah. So $20 billion is a lot of money, but this supply chain is global and massive and has multiple features. So how do you decide, because you're also trying to have particular impact, how do you decide where to zero in on the money?
So it sounds like a big number until you look at the supply chain as a whole and you start to evaluate the challenges in front of us. And so the way that we have structured the investments would be we go through an across-the-board supply chain analysis. So we look at where the U.S. is versus where non-FIOC countries are.
Okay,
FIOC? Yes.
Tell them FIOC. This is
FIOC.
A great expression.
FIOC is a foreign entity of concern. They're the big four. And you will hear FIOC consistently in government speak, but it's the big four: China, Russia, North Korea, Iran. Those are the guys we do not want to be dependent on. And so we do a full supply chain analysis where the U.S. is, where non-FIOC supply is coming from, and identify where our true weak points are. What do we not have in the U.S.? What do we not have in allied countries? And once we identify those real areas of need, that's where we develop, it's called an area of interest, which we release publicly. In the latest round of battery funding, we had 8 areas of interest that we effectively said, industry, this is where we're looking to deploy capital. Please submit applications to one of these 8 areas of interest. You go through a merit review process, you go through an interview process, and we're getting close to the announcement of round 2, which is anticipated to be $3.5 billion.
And maybe by comparison, this morning we were talking with Eric Cantor, and we sort of got into a geopolitical conversation around China, and the Belt and Road Initiative came up. Do you look at the Belt and Road Initiative and analyze kind of what the Chinese are doing and what they're subsidizing as they're almost a competitor, and they're obviously a competitor, but they're a financial competitor to what you might be doing?
There are certainly non-market forces at play. So, if you look at U.S. or allied countries, we need to make money. It's the beautiful thing about the United States is that we are capitalists and we need to be able to have profit margins and attract investors, and that is what our society is based on. We are competing against forces that do not have those metrics. They have subsidized capital from the CCP, so from government parties. They are able to operate at negative unit economics in order to command a monopoly. It's the definition of a monopoly as old as time. But in this instance, you're exactly right. It's through the backdrop of PRC has been planning for the dominance of the battery supply chain for decades. And so what they've done has been extremely far-reaching. They've gone into countries and secured resources. They've built out far and away more manufacturing capacity in China than what the market needs today, such that they're able to flood the market, drive down commodity prices, and make it much more difficult for countries that need to make money to be able to stand up industry. That's one of the many reasons we're really excited about companies like Forum that are able to innovate and come at this problem from a different angle.
Mark Mills had this analogy about OPEC to the oil markets. China is to this world even more powerful. Is that an analogy that is often kicked around in Washington?
It is, except what China is to the battery supply chain is much worse than what you could ever consider OPEC being in the oil and gas business. Again, these are very much non-market forces. Batteries, I feel like, often have this emotional reaction around energy transition and, all of these things. But I'm going to hold your hand and I'm going to say, we need these across the board. Everything that we need today from a national security standpoint needs to have a battery. And so if we need to stand up an industry, it has to be able to compete on different metrics.
Pat, maybe as we turn to you, I mentioned it up front. You're a shopper. You buy solutions and then and you custom fit them, and you are a agnostic, all of the above problem solver. Don't you think in a way that one of the ways this debate has changed so much is we've gone from talking about choosing between flavors to realizing, holy smokes, we are going to need every flavor for a lot of reasons. Talk to us about your perspective. You buy batteries, you build systems, you use portable diesel generators, you know all the flavors, and you're trying to make money, to Ashley's point.
So a lot of y'all have background in gas like I do, and one of the things that we all have taken for granted is the ability to store gas in the ground. Not everywhere, but a lot of places, and that's been really positive. When we were opening up the Texas power market here under Bush in the late 90s, there were two big things that happened in the gas side that we didn't have in the electric. And that was kind of the model we followed, was the one that the Federal Energy Regulatory Commission did to split out the regulated part of the gas business from the competitive part. Just separate them out, quarantine that monopoly, and get on with things. And that worked really good. The gas restructuring did. And so we've copied a lot of that to do electricity. And so the big thing missing, though, was you can't store electricity. Well, you couldn't. 2018, the world changed. It was actually before then, but the economics made a lot of difference. And it was driven, as I think Ashley pointed out, a lot by CCP subsidizing that. The short-term side of me says if they want to give away their money, as long as I can block their malware from getting onto the grid, which we have to spend a lot of time and effort for due to a Texas state law, which was correct, then fine. But I'd love this to be my future rather than me buying the cheap stuff. But I'm a user, and so like the Walmart shopper who doesn't think about what it's doing to Main Street is like, I'm going in there. I want to get the best built battery, and CATL is a phenomenal product, I will say, and their warranty service is great. But we are able now to take electricity when it's cheap. and being overproduced, and might have even like take solar power in the middle of today, probably in the afternoon. I'm sure there was all our batteries were filling up at 9 a.m. 9 to noon is really the time when you can fill up a battery for about as cheap as you can. And that just 4 years ago, we'd have to do that in the middle of the night when you'd have a lot of excess wind on the system, and that was cheap as well. So, that's just the industry has changed a lot, but that ability to break the tyranny of the temporal bond that electricity had with this product that moves at the speed of light was just so revolutionary. And so plugging that into markets and getting efficiency, now we're all just, we here in Texas and the other states, California, some in the East, we're all just now figuring out how to make that work in a way that makes our power grid more efficient, more resilient.
Could I just ask while we're right on it, if I buy a Chinese battery and they've subsidized it, what is the sense of how to what extent they've subsidized it? Like the price I'm going to pay relative to the actual price, is that I'm just curious how much they're spending to get these batteries sold.
It's hard to know. I mean, I think there's about a 25% delta between a good, high, kind of a very economical Korean or Japanese battery,
Okay.
Which is a lot. But I mean, but it's not like 90%. So there's a gulf there. But you wonder if they price just like the coal guys always did, was just price a little bit below gas, so the coal would win. So it's hard. I mean, they're with a big checkbook that the CCP is writing from. You don't know how much more checks they can write.
But were you also just alluding to something that's kind of interesting? Because people tend to think, like if you bring up a Chinese EV, you tend to think, oh, it's subsidized and da-da-da-da-da, and then you almost think it's not that good. But you were kind of pointing to Chinese batteries, Chinese EV, like the quality. Like there's two problems here. They're subsidizing and being very aggressive. The second problem is the stuff's pretty good, and that's an issue for us.
Yeah, it's really good. I mean, my on-time reliability is above 99% year-round. And that includes all the things that could go wrong with the inverter, with the interconnection to the local utility. So, I mean, this ERCOT, the state grid of Texas, really wants to make sure that we're reliable and dependable. And because they're counting on us. When the sun goes down, that's the most interesting time. It's the only time I make money. Honestly, probably 68% of our revenues are in hour ending 20, hour ending 21 last month. The sun is now setting a little bit earlier each day. But, that period when the sun goes down and before the wind kicks up, and it's a really steep ramp. Now with 25 gigawatts of solar, the gas plants cannot kick on that fast. And so that, battery's instantaneous, a quarter of a second at most. So we really kick on quickly and help ERCOT manage that down ramp. So that's a nice thing. I mean, it's not a earth-shattering thing. It's just an efficiency thing. And quite frankly, I know the electric business is getting layered in with all these policy issues, but at the end of the day, if we can just be about what is efficient and do the efficient thing, use the government. I heard it from the last speaker as well. Use the government for actually, you said it better, Ashley, is use the government for what the market can't do. And be that forward seater as it was on so many things in our life. I really do think the labs of the country have been a humongous natural, as Dan Briette that said that, the natural resource that they bring, and let the innovators and creativity people here make that move on down the road. We'll get there. I can't wait to be his customer. I remember going to a party at Michael Skelly's house and meeting you for the first time, Mateo, and thinking, Rust? And then I went home and researched it. And I mean, I remember calling back. I called a guy who's now in the PUC. I said, I researched it. That's actually going to work. Can you believe that? I mean, we're all geeks that just grew up. So, it's kind of fun to see it really happen.
I know. Mateo, maybe we could turn back to you for a second a little bit around the technology and the challenges of everything you've been through and now you're moving to production. The people, the staff, the team, like where'd you find them? Where do they come from? Do you need more? Like just talk about your team, because I think we've heard that's another theme today is just talented, skilled workers from electricians through to AI specialists.
Yeah, when we started the company 5 years ago, there are actually 5 co-founders, which is fairly uncommon. But the reason there were 5 of us is we knew this was going to be a hard problem. It was probably going to be harder than whatever we could anticipate. And each one of us had already been in the battery industry for more than a decade at that point. And we liked the idea that none of us was a first-time novice trying to figure this out. And we also had, in that way, multiple technical shots on goal. So Iron Air is the one that we're commercializing, but we had other ones as well. And that really speaks to the fact that we really had to pull on our network from the very beginning to flesh out the company and the skills that we went. Initially, it was really research scientists, right? So the company was founded and headquartered in Massachusetts, and we're pulling very heavily on MIT and the sort of academic material scientists that really drive that first phase of a hard tech, deep tech battery company. And then we added engineering in California once we had sort of passed the critical stage gates of the technical sort of science development. And we did that there in California because California right now is unmatched. Maybe Texas is coming up right here neck and neck for integrated system engineering. Mechatronics is sort of the term that we use. And, Tesla is largely to thank for that, frankly. But previously there's other companies, SunPower and, the Silicon Valley, the old manufacturing Silicon Valley as well. And then as we added on the manufacturing piece over the last couple of years, that's why we're in the Pennsylvania region, Western Pennsylvania, West Virginia region. The industrial knowledge base for how to make things is there too. I will say, though, that there is a very huge competition right now to get the manufacturing and process engineers, the industrial engineers who know how to do this for the first time. And, it was a major failing of the United States that we basically invented lithium ion. In fact, UT Austin professor, Nobel Prize winner who invented lithium ion. And then it was commercialized in Asia, first in China, then Korea, first in Japan, then Korea, now China. And we can't make that same mistake. But it does mean that we need people who know how to make things. China is competitive on just a raw skill basis for manufacturing today. Tool makers and equipment set makers, they are absolutely world class right now. And for the newer inventions that we have or the newer technologies that we're bringing to market, we need to make sure that we're not just really good at the inventive stage, but on the industrialization and scale-up stage as well. And so we compete very heavily for that talent. And we're pulling from Tesla, and we're pulling from Apple, and we're pulling from all the top folks that today know how to do that. And hopefully we're also building up a base of additional talent that will hopefully go on and seed a lot more companies beyond Form.
So sort of a naive question, battery manufacturing, does it, because you mentioned pulling people from Apple and these types of places, does it resemble more of electrical component manufacturing, or does it resemble more of a, metal bending? Like, how do you mate those two? And if we were walking your factory floor, what would we see?
Yeah, so Form's manufacturing process actually encompasses sort of the 3 major types of manufacturing. So we have sort of material processes for the electrodes. We have raw materials that are showing up in powdered form, more or less, and then we turn those into functional battery electrodes. So that's sort of one type of manufacturing. Highly automated, very little intervention that's happening there, relatively high volume. And then we have cell assemblies. So you take those electrodes and you put them together into an individual cell, and that looks more like an automotive manufacturing line. There are humans in the loop. There's robots, large sort of 6-axis robots that are going from station to station. Anybody who saw that line would recognize it as a manufacturing line. The earlier step, you're kind of like, there's a big machine, I can't tell what's happening. But the middle one is sort of very much in that vein. And then the last one is more like a RV or a airplane manufacturing, where those enclosures are getting populated, very manually, very large stations that sort of are moving very slowly and sort of leaving to get to the end of the line there. So we pull from all of 3 sort of major types of manufacturing, and that's good and bad, has its challenges and opportunities.
So maybe one more thing, because you mentioned it when you guys were coming together and forming the company, you thought about a lot of different types of battery technologies. Could you just maybe talk to us a little bit about that process, and also maybe in so doing tell us, do you think we're going to see a world with lots of battery technologies with different applications, or are we gradually going to see a core set of the best that win out? Which way is maybe a way to think about this?
Yeah, so when we started the company 7 years ago, we were intent on solving a problem, we didn't show up with a solution that we were trying to shove into the market. And the problem we were trying to solve was that multi-day period of intermittency. And that really comes out of the techno-economic analysis, very complex co-optimization analytics, essentially, that one of my co-founders, Marco Ferrara, did. And that pointed us to the 100-hour duration to target, because that's what falls out of the analytics as being differentiated functionally on the electric system. So you're not solving a new problem with 20 hours or 40 hours, really. There's sort of a valley of value in the electric system from 10 to 12 hours until you get to 100 hours, where you are then able to solve truly a different problem, right? And absent 100 hours duration, you're still keeping around all your thermal resources, right? Or maybe you're using, CCS on top of those. But that's why we targeted that. And we didn't pick electrochemistry either, batteries, right, either, because we wanted to cast as wide a net as possible. So we looked at thermal approaches and mechanical systems and you name it. We picked electrochemistry because it is fairly good from an energy density standpoint. And it's also very good from an invention standpoint. So it's hard to invent new physics that get the gears to be more efficient, right? Humans have sucked a lot of, that knowledge out of that sort of realm of things, and, thermodynamics as well. But you think about sort of the frontiers that are still being pushed on the electrochemistry, there's a ton of room to run there. And, to the AI question as well, if AI is going to have the biggest impact on sort of which form of energy storage, it's almost certainly going to be electrochemistry, because new material synthesis, new sort of electron reduction potential pairs are going to come from AI more likely than sort of big breakthroughs in the other types of energy storage you might pursue. So that's why I'm particularly bullish on electrochemistry generally. And we've been proven right in that respect. So we thought that for example, the energy density, or the available energy per gram of iron, the theoretical limit had been set. This is sort of by the published literature at, you don't have to worry about the exact metrics here, but 960 milliamp hours per gram. And what we found in our own process of elaborating the technology is, in fact, it's 1260. So we increased by 30% the theoretical limit that had been ever observed. Think about all the human interaction with iron for steel making and corrosion prevention and everything else. And there's things to learn about iron still, especially for this new application. So we're really bullish on sort of the pathway here. The other alternatives that we considered electrochemically were at least entitled to the same pathway in terms of cost and therefore duration. So very, very cheap, very, very abundant materials, sulfur, other anions, oxidation reduction pathways, where you're essentially using oxygen, as your key sort of driver there.
Well, I'll apologize because I got one more down here. And then actually, get ready. I'm coming back. Everything you're describing, the complexity, the skill sets, that you're doing, Mateo, how do you compare doing it in a startup entity versus, I'll just pick a name, Honeywell or some big industrial company says, we're going to form blank, here's the new division. And can you contrast that? Because innovation happens in startups, but there's a lot going on here that a big company already has a lot of the tools. Like, how do you see that?
Yeah, and when I was at Tesla, we went from 300 people to 30,000 over my tenure there. Wow. I was there 2009 through 2016. And while there, I worked a lot with Daimler and Toyota. That was my day job at Tesla. My night job was starting the energy business. But I saw up close, sort of that impedance mismatch between a small, scrappy company, relatively speaking, and then a large, established industrial company, Daimler or Toyota in that case. And the fundamental difference is speed. That's really what it has to come down to, and because that's the only advantage you have. You don't have more resources. You don't have more money. You don't have more political heft. The only thing you have is sort of your own wits and the ability to move fast. And if you squander that in the first couple of years, you're dead. And so we've used that as really an animating function here. The term fail fast is probably overused, but it's important to keep in mind, you do have to figure out what really does work. And the way that we sort of characterize that functionally inside of the company, inside of Form, is by thinking about risk at all times. And my job as the CEO essentially is to make sure that we are pursuing the highest risk-killing path that we have. And that means you have to understand your risk and then go kill it, but do it quickly. And the risk tolerance, of course, is very different for a large company, right? They're in a conservative preservation mode, and we're in a acquisitive, risk-killing mode. And so it really does have to translate to how quickly you move and the right amount of risk that you're taking and killing in pursuit of the opportunity that's there.
Oh, that's fascinating. Actually, I was going to ask you because there's so much national security at stake here. Do you end up visiting with your counterparts in other Western countries, and what's sort of the cooperative dynamic that is going on and all that?
Yes, absolutely. A tremendous amount of cooperation across our allied countries.
Who's your favorite ally?
Well, so I, prior to this, a couple jobs ago, I started a mining company in Australia. So nickel mining is called Black Mountain Metals. And so I'm most familiar with Australia. Okay. So we can count them.
And what are we doing anything tangible with them? Are they co-invest or co-funding, or what's the nature of the cooperation?
Yeah, so no co-funding. We also cannot fund projects that are in a different country. However, what we can do is effectively go through like a matchmaking effort around, let's say Australia is producing manganese and we don't have a manganese opportunity here. We do, but this is just illustrative. But we're building out a manganese sulfate plant. And so we need to source manganese concentrate from somewhere, or we don't, but the company does. And we can effectively make those introductions to ensure that if a company is having trouble sourcing something from non-FIOC sources, we can step in and effectively help with that matchmaking.
And actually, when the IRA, it came out and now we're implementing, but one of the discussion points was, what if a Chinese battery company, just to use that as an example, wants to make batteries here? Well, what if some of these organizations come here? How do you see us reacting to that? Are we gonna? I know it's a little bit controversial, but what do we do there?
So they're welcome to come and make things here. They can't get government funding. So FIOCs, there is a very specific definition of a FIOC. I encourage all of you to Google it. It's riveting.
It's going to be the most searched word here.
You too can speak like a bureaucrat, which I know is everyone's goal. So the FIOC definition is even if it's a subsidiary, even if it's not based in a FIOC country, if it's owned over a certain threshold by a FIOC entity or a government, a FIOC government, then it itself is a FIOC, and therefore they cannot receive government funding.
Pat, let me jump back to you. It looks like so many of the fundamentals in the power world, adding more intermittency, needing more power, having weather be more influential of our systems, these types of things, it just seems to point to more need for Mateo's batteries and more need for companies like yours that show up and problem solve. Like how can that not be the future that we're headed to? As you think about the risk to your business or the risk that we have this wrong, how can that kind of sort of not be the case?
I think for so many of us in this room, we've kind of had an energy economy based on growth and on the economics of plenty. I mean, we saw some data throughout the day about that. And so I think, we saw through a very arresting episode what happened in COVID when demand went down. I mean, it all kind of came apart. Thank God Congress actually was inspired to do something. I hate that it added a couple of trillion to my children's debt, but it did what would have been a downside of not doing that. So anyway, but demand in energy after a generation of being relatively flat, this is really, I would say, electric power energy, but it's probably true of all the energy, is really on the uptick now. I mean, a lot of things are now being electrified. You've heard about all that. If we want to do that in a lower carbon manner, you have got to have the ability to store power at not just the marginal stuff that we're doing. So Texas has 80 gigawatts of demand. The hottest day this summer was 86,000 megawatts. There are about 6,000 to 8,000 megawatts of batteries. So already 10%. That just doubled from last year. So that's kind of we're not making a whole lot of money right now. So that's kind of a stasis point probably there. But as that 80 goes to, as ERCOT projected, that would be 130. I mean, it almost pops my mind. By the end of this decade, because of the influx of data farms, of relocating industry, of people moving here, AI issues, as well as electrification of transport, that's a whole lot of new type of storage, and it's going to be a different type. We're the market right now sending a signal that 1.5 hours is kind of the sweet spot on your kind of rate of on your investor return. That ain't going to last. I mean, this is the long play. You've got some of my competitors are doing 4-hour batteries already, or they're buying enough lithium ion to do 4 hours. That has a diminishing return for that. That product was designed to be portable, but what he's talking about is a fixed battery that stays there and doesn't have to move because you don't need it to move. You just need it to level the system out. I did get a text from somebody. The other thing we didn't have in gas was flexible load and the ability to do demand response. So we didn't have storage and we didn't have flexible demand response. Now, because of computers and all, we have them both.
So, Mateo, you didn't necessarily say this, but I'm curious, when you were thinking about which flavor you would choose and embrace, did you like it that the iron air battery is not tied to mining a bunch of certain kind of minerals and that usually come from certain kind of places, and was that an attraction?
Oh, absolutely. I mean, the fundamental drivers for the success of what we're pursuing is cost. And, the primary challenge with having conflict elements of any kind is, in the end, it will be cost. You're going to pay for that conflict. You're going to pay for that. It could be political conflict or, any other kind. It doesn't really matter. There's a cost associated with it. And, the United States has phenomenal reserves of iron. They happen to be lower grade than what you find in Australia or in Brazil. But the Iron Range in upper Minnesota and Michigan has phenomenal amounts of reserves still available. And so one of the pathways we're pursuing is how do you take perhaps that lower grade ore and process it so that you can still use it for our needs. But absolutely, we were looking for things that didn't require exotic supply chains, or even not even exotic, but today what our standard supply chains, just really simplify things and source materials and processes that are available right here.
Ashley, do you see many marriages or partnerships or just otherwise relationships happening between mining companies and battery manufacturers or battery technology players? Because they're very different industries, and it's spread all over. What do you see in that area?
Yeah, so there's actually quite a lot of interesting quasi-vertical integration on both sides of the spectrum. So on one side, you've got the mining guys. On the other side, you have OEMs, so all of our U.S. automobile manufacturers. If you look at what happens in China, it is full vertical integration from raw material all the way through who is making the battery and ultimately even who's making the vehicles. And so they don't have margin stacking across their supply chain. They don't have the things that we see. It's all flow through. From a mining company becoming vertically integrated, traditionally, where you see that cutoff point is sulfate or potentially PCAM. So the kind of steps in the chain would be you mine it, you concentrate it, and then it goes through a refining process, and then you make sulfate out of it. So sometimes mining companies will make the sulfate, and then after that it's PCAM, CAM, you get a battery, and then the battery goes into its end use. And so it's quite interesting to see where mining guys are going up to in the value chain versus where OEMs are also coming back to. You're seeing OEMs taking stakes in mining companies, which I love to see. I absolutely love it because I think it's vertical integration is the best shot we've got at truly being competitive.
Yeah, I was thinking Cameco, the uranium miner, has combined with Westinghouse. So that's not a business model that is instinctive. But when you sit there and sit through the presentation, and it's basically like, hey, from way upstream all the way down through the product, we understand this. So it's striking.
Yes, I mean, look, when Ford was first created, they were fully vertically integrated. They owned rubber plantations in Brazil, and so I'm certainly not encouraging everyone to do all things. I think it's very inefficient, but there are some instances where vertical integration is the way that we become and maintain competitiveness.
So Pat, Ashley said it. We're capitalists. We try to make money and all this stuff. As you look at the battery space and the power space, and let's just say you didn't have Hunt Energy Network, and you were just looking at all this and saying, where should I put $1 in the power world to make $1? Should I go into batteries? Should I buy stock of a utility? Should I give it to a fund that does power? As you look at the power world, now I know everybody's laptops just came out. No, I'm joking. But as you look at this space, how do you think about making money in this space broadly?
Where there is demand, there must be supply. And we are short on supply. We saw that in Texas. We've seen that in Texas now. Not this summer. It's pretty mild weather, but next summer will be hot as hell. So you never know. But that's your basic economics, is the curves that go like this. And when the supply is too low, then the price goes up, and high prices are the cure for high prices. So that kind of economic rationale works. I would say full up and down the chain, from the equipment that's being supplied from my two colleagues here that talking about that, to providers that are optimizing. And I'm a middleman. I guess I'm between a middleman, because there's a customer paying me, the ERCOT customer, and a supply that is coming in. So I'm just taking somebody else's electricity as cheap as I can, selling it high as I can. We also can replace infrastructure. People that are thinking we've got to build this grid up for $15 billion just to beef up the Permian Basin. I wonder how much of that could really be solved more efficiently by storage, because the storage is really a replacement for utility infrastructure. Because otherwise, if you didn't have storage, you build to the absolute maximum peak you'll ever need. Well, if you can do it this big and let your storage kind of move things around, it's a lot more efficient system. So again, the gas system was built that way, as you all know, with summer storage being used in winter peak. Let's do the same thing on the electric thing. So where's the money to be made? Throughout. I mean, even at the demand side, we're certainly working with large customers that want to manage their energy consumption and do it at the right times. Use grid power when it's cheap, self-generate when the grid power is too expensive. That rationalization of the system's good. There's money to be made doing that. So it's is it the home run? I'm going to get the East Texas oil field, or I'm going to hit Prudhoe Bay. Probably not one of those. I think there's a lot of little ones of those everywhere throughout a system that's electrifying like no other time in our lifetime.
I was having a flash I feel like that was the Dr. Weber question. He said when he was in college, everybody just took the highest paying job. So I just asked you, where's the money? Anyway. Well, Mateo, Pat, Ashley, fantastic. Thank you so much. Can I give a round of applause for these guys?